In this lesson, we're going to start quadratic functions. This is going to be broken up into a few different pieces, but let's start with what we already know about quadratic functions. Based on the parent function, we know it should be something with an x squared term. The parent function y equals x squared starts at 0, 0, and then we can find the other pieces by plugging in numbers if we need to. 1 squared is 1, but so is -1 squared. 2 squared is 4, and -2 squared is also 4. If we went out to 3, 3 squared would be 9, which is a little bit off the chart for this one. But it follows this basic shape, and we can use transformations to move and manipulate this graph. So if we want to graph this function, y equals x minus 3 squared minus 4, this function has shifted right 3 and down 4. So you would take every single point and move right 3 down 4. What's nice about this format with transformations is I can see that the vertex of that parabola has shifted right 3 down 4. So that point at 0, 0 is now 3, -4. And it would follow that same format, that same pattern of out 1, up 1, out 2, up 4, and out 3, up 9. So our new quadratic function looks something like this, with this vertex here at 3, -4. We also have something called the axis of symmetry. The axis of symmetry is where a parabola folds directly in half. In this case, it happens to be at x equals 3. Every parabola will fold in half exactly through the vertex. This vertex was at +3, -4, and since the parabola opens up, we see it would be a minimum. If we have transformation form, then we can use that to find the vertex. So transformation form looks something like this. So we have y equals a x minus h squared plus k. We can see if it moved left or right, up or down, and if there was some type of vertical stretch or shrink, something going on to the function as well. Oftentimes this is referred to as vertex form because you can see the vertex pretty easily. In fact, I'm more likely to call it vertex form than transformation form. So based off that first example, we have 2x minus 3 squared minus 5. This parabola has shifted right 3 and down 5, but was also vertically stretched by a factor of 2. Even if it had shifted right 3 and down 5, it's still opening up. So in this case, the direction of opening is up with a vertex of 3, -5, because it shifted right 3 down 5. This value at the bottom is going to be our minimum, and that happens to be the y coordinate of your vertex. So it has a minimum of -5. The axis of symmetry is where this parabola is going to fold right down the middle. This is going through the x coordinate of the vertex, so it's at x equals 3. If I sketched a very rough sketch of this graph, it would have a vertex down here at 3, -5. It would open up, and it's a little skinny just because of that vertical stretch by a factor of 2. We're not trying to get a full detailed graph, but it does give me a little sketch. In the second example, we have f of x equals -1/3 x plus 2 squared plus 4. This one has shifted left 2 and up 4, but there were other transformations that happened. So there's this reflection across the x-axis, this negative reflected over the x-axis. There's also this vertical shrink by a factor of 1/3. But because it was reflected, this is now going to be opening down. Even though it was reflected, the vertex still shifted left 2 and up 4. Going left 2 makes that -2 and up 4 to +4. So the vertex is now -2, 4. With it opening down, we're going to have a maximum value, and this will have a max of +4. That happens at x equals -2, which is also the axis of symmetry. So to do a rough sketch, let's go to -2, +4. And we're going to make our parabola turn down. It is a little bit wider because it was vertically shrunk by a factor of 1/3. But this is our vertex here.